Our presentation outlines the regeneration of Point Pleasant Park post-Hurricane Juan.
On September 29, 2003, Hurricane Juan hit Halifax and caused horrific damage to the city and the environment. This hurricane was the worst storm to hit Halifax since 1893, and almost all the destruction hit Point Pleasant Park, causing the loss of 70% of all trees because of the aged forestry. The trees in Point Pleasant also have very shallow root systems, which contributed to the tree loss. It has now been 22 years since Hurricane Juan hit Halifax, and Point Pleasant Park is slowly starting to recover from the catastrophic storm. This experiment aims to observe secondary succession and how competition may have been a factor. After the hurricane disrupted the environmental conditions, plant species underwent exploitive competition. Exploitive competition is when an organism reduces the availability of a common resource. This impacted the species that dominate the area, which influences their fitness rates. The main objective of the study is to determine how the structure of Point Pleasant tree community has been impacted over the past 22 years of secondary succession. We predict that the Shannon Diversity Index to increase over time as more species colonize the recovering area.
All data since 2004, with the exception of 2005, 2007, and 2016, due to other hurricanes, and 2020 due to the COVID-19 pandemic, have been collected in Point Pleasant Park, Halifax, Nova Scotia, Canada, by students and teaching assistants in BAL 2016. As you can see in the figure, 2 sites are located further away from the ocean, closer to the middle of the park, and 4 are located closer to the edge. The park was surveyed, and these study sites were picked based upon the highest impact of forest structure due to Hurricane Juan. Each site is 20 by 20 meters. The next slide will explain the methods behind how the data was collected.
Methods allows us to interpret results, explain the significance of our findings, and answer the research question. On the next slide, we will explain the 5-step process used to conclude our results. Site design allowed us to get our plot established. Plots were established based on the highest tree structures impacted by Hurricane Juan. The study plots were 20 by 20 meters in length and width. Data collection shows us the number of individual species per unit of area that was measured. To qualify for data collection, all trees must be a minimum of 2.5 centimeters in diameter and have a breast diameter height of 4.5 feet. Data processing will allow us to calculate total density richness, diversity, and evenness per year for every site. This is important because we can compare differences and similarities as time goes on. Data metrics includes 2 calculations: the Shannon Index, then Pailou's evenness. Finally, graphing shows the linear regressions computed for breast diameter height, red spruce, red maple, and Pailou's evenness.
A linear regression was used to examine if the diameter at breast height, DBH, has changed over time. We collected data on the tree size using DBH methods of 4.5 feet above the soil and anything greater than or equal to 2.5 centimeters in diameter for each study site. We tested 2 hypotheses. Null hypothesis states that DBH has not changed over time, and the alternative hypothesis states that DBH has changed over time as the forest recovers from Hurricane Juan. DBH has declined from approximately 34 centimeters in 2004 to approximately 6 centimeters in 2005, overall showing a weak negative linear trend with an R value of 0.491. So, 14.91% of the variation in DBH is due to time alone. Overall, this is indicating that DBH length has decreased in trees in Point Pleasant Park, as well as the p-value is less than 0.5, allowing for the null hypothesis to be rejected and the alternative to be accepted. Here we will discuss how DBH changed over time and what will happen as the forest moves towards its climate. The diameter at breast height of trees is a key indicator of forest structure over time. After a major disturbance like Hurricane Juan, it significantly alters forest composition. The linear regression showing a weak negative trend in DBH suggests that the tree's circumference is smaller than before the disturbance. A larger hurricane can remove many large mature canopy trees, leaving smaller trees to establish themselves. This results in the overall sites becoming dominated with smaller stems, lowering the DBH. This is shown as there is a decline from 2004 approximately to 2016. Then there is a small upward trend. This means that the smaller stems are growing and stabilizing towards its climax community. Additionally, trees will eventually become larger as the population grows, natural thinning due to competition. Eventually, trees will dominate the canopy again, resulting in fewer but larger trees in these sites. As years continue, this will lead to a steady increase in DBH as long as it is not disturbed again. Overall, having a larger DBH will benefit Point Pleasant Park, allowing for more wildlife habitat and better air quality for the park and the Halifax region around it.
A linear regression analysis was conducted to measure the red spruce per 400 meter square plot across 6 sites in Point Pleasant Park following Hurricane Juan. As shown in Figure 3, a weak positive linear trend showed R squared as 0.1306 and a p-value of 0.004. We can assume that there is a 13.06% of variation of density is due to years over time. The null hypothesis states that there is no linear relationship between the year and density of the red spruce. Because the p-value is less than 0.05, the null hypothesis is rejected. Because of this, we can assume alternative hypothesis stating that there is a linear relationship between the year and density of the red spruce. The overall conclusions drawn from this graph is that there is a slow, weak linear increase in red spruce trees across the 6 sites in Point Pleasant Park since the hurricane. Figure 3 shows a rapid increase from 2008 to 2014. From that point on, there is more growth in the red spruce. However, it is more dispersed throughout the years. From 2022 to 2025, there seems to be a constant state of red spruce per 400 square meters. From these results, we can infer that there will be a continuous gradual increase in red spruce over the upcoming years. A linear regression analysis was conducted to measure the red maple per 400 meter square plot following Hurricane Juan. As shown in Figure 4, a weak positive linear trend showed R squared as 0.1351 and the p-value is 0.003. The null hypothesis states that there is no linear relationship between the year and density of the red maple. Because the p-value is less than 0.05, the null hypothesis is rejected. Because of this, we can assume that there is a linear relationship between the year and density of the red maple. The overall conclusion drawn from this graph is that there is a weak linear increase in red maple trees across the 6 sites in Point Pleasant Park since the hurricane. Figure 4 shows a rapid increase from 2008 to 2014. From that point on, there is more growth in the red maple. However, it's more dispersed throughout the years. From 2022 to 2025, there seems to be a constant state of red maple per square meters. From these results, we can infer that there will be a continuous gradual increase in the red maple over the upcoming years.
Results 3 shows the regression analysis of pilot evenness across 6 sites in Point Pleasant Park, Halifax, Nova Scotia. We are comparing the pilot evenness post-Hurricane Juan. Our R value is 0.0359, and we had a p-value of 0.08, which indicates a negative weak linear trend, which also means we had to reject our null hypothesis. The weak negative linear trend also shows a decrease from 2004 to 2005. Only 3.6% of the evenness is explained by year with the regression analysis value of 0.0359. Because J is closer to 1 in 2004, we can say that the individuals were more even. As the years go on, the number of individuals decreases because J is going closer to 0. As the years go on, pilot's evenness decreases. From this data, we can predict that the distribution of individuals will continue to be increasingly uneven.
Based on the trends of data observed and calculated, Point Pleasant Park is recovering from the damage of Hurricane Juan. Fast-growing, light-demanding species decline as the canopies fill in, and competition for light increases. Based on the observed trends, Point Pleasant Park is in a mid-late secondary succession stage. We can predict that red spruce and red maple trees will continue to dominate as light levels decrease. Larger average DBH values can be expected as trees age and structures progress. Species richness and the Shannon Diversity Index are predicted to continue increasing as diversity stabilizes. If these trends continue, Point Pleasant Park will continue to mature and be shade tolerant, increasing canopy tree species.
Question 1 states, how has the removal of larger trees post-Hurricane Juan influenced the growth conditions for new seedlings to succeed, and how might have changed the competition between species for space and resources? Well, the removal of large trees will increase growth conditions for new seedlings that need a lot of light to grow. However, it will decrease success for seedlings that are shade tolerant. In terms of the change in competition, it will shift to less competitive in 2 ways. The first way is underground. The larger trees take up a lot of resources underground in the root system, and so with fewer larger trees, more resources are available for the smaller seedlings, as well as the increased decomposition of the fallen trees will benefit in increasing soil nutrients over time. The second way is above ground. There will be more space for new plants to establish themselves and generate more seeds that can be dispersed throughout Point Pleasant Park.
Question 2 states, how could the urban pressures change the future of the forest succession in the park? And is there any evidence in the data that suggests urban factors are slowing down the growth of the forest? Urban pressures can change the future of the forest succession in the park in either a positive or negative way. Pollution has a major implication on succession because it creates poor air quality. And with an increase in urbanization in Halifax, this is a serious consequence to consider. Another pressure to take into consideration is the brown spruce longhorn beetle. It arrived in Nova Scotia from packaging in container ships, which were docked at the Port of Halifax. The port is directly across from Point Pleasant. The female beetles lay their eggs in the bark of the trees. Then the trees have a life of expectancy of 1 to 5 years. Forestry ecologist Bill Friedman states that the only prudent thing to do in terms of sanitation is to take down the dying trees as quickly as possible and debark them. There is hope that this will limit the attacks of the beetles.
Question 3 asks, what do you predict the reestablished forest community to look like compared to what it was prior to the disturbance? Before the disturbance, Point Pleasant Park was dominated by mature canopy trees, limiting the light availability for early successional species. The soil was thin and undisturbed because of the trees that dominated. This led to less diverse species benefiting the large, mature species. After the disturbance, there was a major loss of canopy trees, which increased the light availability. Patches of exposed soil benefited new pioneer plant species. We predict that the reestablished forest community will have young, light-tolerant species that colonize the area with an increase of overall diversity.
We would like to thank Dr. Joanna Zegras for the data analysis and guidance, Dr. Allison Schmidt for the previous data and knowledge, and finally all the students and teaching assistants in Val 2060 Ecology class at Dalhousie University who helped us collect this data for the study. Thank you.
These are the references that we use to support our analyses and our conclusions.